Hello and welcome to TN Academy. Today we're doing question 3 where we're given a particular park that has a rectangular garden in it of area that's not given and a concrete path surrounding it. The park has a total area of 1,200 meters. Alright, and it is said that the width at the north and south side is 2 meters. All of that's written in the diagram minus the 1,200 meters being the area. And we're given some length x that is greater than 3 meters and less than 300. So for the first question, we're asked to show that area is equal to 1,212 minus 4x minus 3,600 over x. Okay, so to solve for this question, we know that area is equal to 1,200 meters squared, and area is also equal to length times width, where we'll have our width be x, so Lx. And then if we arrange for this equation, keeping our unknown variable x in, we can write our length as the area divided by x minus 4, the two additional side lengths. And then for our second factor, width, we can simply write it as x minus the other two additional side lengths. So that when we write this out for the area of the garden, we get, we'll multiply, this is the length of the garden and the width of the garden. We will get x minus 4. And then when we distribute these values, get 1,200 minus 4x x plus 12. Okay, and this is of course after distributing the terms and simplifying, and then for our final step it'll just be 1,212 minus 4x minus 3,600 over x. Okay, and that's our answer to question A. Now for question B, we're asked to find the possible dimensions of the park if the area is 800 meters, okay? So by using the equation that we've just created for area, we can set area to 800 meters and then solve for x. And then we can solve for our side lengths, our width and length, using the width and length portions of our equation. Okay? So if we say that A, which is now equal to 800 meters squared, is equal to 1,212 4x over x. Subtract 1,212 from both sides. Okay, continuing on. We can, of course, do the subtracting here, and then multiply all terms, both sides by x. Multiply all the terms by x, so that we get negative 412 x, 4x squared minus 3,600. And then we're going to actually bring this term over to the other side again, so we're going to add 412x to both sides. So that we get a quadratic equation. And for this, we can just use the quadratic formula, which is x is equal to negative b plus minus square root b squared minus 4ac over 2a. where our first term, the coefficient is a, the coefficient to our second term, the x term is b, and the last term without an x is c. Okay, and then if we solve for this, we can find our two values of x, where we should find that x can either be, after rounding, 9.64 meters and 93.4 meters, which means that when we use those two equations from the beginning, that our width is equal to, one moment. So these would be our widths of the garden, as I have assigned it. Yeah, width, and that's of course accounting for the subtraction of 3. And then the lengths of the garden, we can find them by using the equation that we've created of 1200 divided by x, which are the x values which we found from our quadratic equation, and subtract 4 so that we find the lengths, the possible lengths with their corresponding widths, can either be 124 meters after rounding or 12.9 meters. Okay, now for our next question, we're asked to find an expression for dA over dx, the rate of change of the area. Okay, so if we go back to our initial expression and we take the derivative of it with respect to x, this is a constant, so it will of course cancel out, and we just get -4 minus 3600 over x squared. Okay, and that is our answer to dA dx. Then for our next question, we're asked to use our answer from part C to find the value of x that will maximize the area of the garden. So we know that maxima is achieved when our derivative is equal to 0. It's because it'll either be a peak or a trough, but it'll be a maxima or minima. But in this case, we're looking for the maxima. Anyhow, we set our equation equal to 0, and we find the associated x-intercept, and that will be our point where the area, again, is maximized. So we say that 0 is equal to -4 minus 3600 for x squared, and then we, of course, subtract or add 4 to both sides. 36 x, and then we can, what should we do? We're gonna inverse, flip both sides, and then multiply both sides by 3600. So this will turn into 1 over 4, and the other side will also be inversed, okay? Yeah. So then we get 3600 over 4 is equal to x. And when we solve, we can't forget too that the x was squared. X squared is equal to 900, and then when we take the square root of both sides, x is equal to 30 meters. Okay, and that's our answer for question D. And then for our final question, we're asked to find the maximum possible area of the garden. Given that we already have the side length x that will maximize the area, we just use that side length in our initial equation. Okay, which is a at 30 meters equal to 12 minus 4 times 30 minus 3,600 over 30 meters. And then, yeah, all we have to do is compute this to find the maximal area of the garden. And after computing this, we find that the maximum area is about 972 meters squared. And that's all for the this question today.